Okay, let's start with the new topic, that is electric field. Electric field. So let it be two charges, Q1 and Q2. Let it be both are like charges. Okay, both are like charges. So if let it be two charges separated by a distance r, as we know that these two charges repel each other, but there is no contact, there is no physical contact between them, but still they experience a force without any contact. So sorry, Iram. So let it be two charges, either let it be two charges, Q1 and Q2, separated by r distance. So as we know that these two charges either repel each other or attract each other, but there is no physical contact between these charges. So what happens? So there is something by which these two forces either repel each other or attract each other. That something is known as electric field. What happens? Let it be a charge. It creates a field around it. It creates a field around it. Some kind of influence. It creates some kind of influence around it. And if you bring other charge nearby it, then this charge either repel or attract. That is due to this field. This imaginary space is known as electric field. Fine. This imaginary space is known as electric field. Is it clear?
Yes.
So this is a let it be this is a charge. It creates a space around it that is known as electric field. And if you bring any other charge nearby it, let it be this is positive test charge. And if you bring nearby it, then this charge will experience a repulsive force towards right due to this electric field. So electric field basically, it is a space. It is an imaginary space. Imaginary space. Fine. It is an imaginary space which is created by a charge around it. Fine. Second, it is an imaginary space which is created by a charge around it. Basically, electric force is a non-conservative force. Okay, so electric force is a non-conservative force. Is it okay? Shall I move further?
So,
Yeah.
so the test charge will also have its own field, right?
Yeah.
So won't it attract? Sorry, won't it the charge repel
Look what
due to
happens.
its?
This charge is very, very small. This test charge is very, very small. It also creates a field around it, but the but the intensity of the field created by the test charge is very negligible comparatively to this charge. That's why this charge will exert much more force than this test charge.
Okay.
Now definition, it is defined as force acting per unit test charge. So electric field is defined as limiting value Q naught tends to 0 F over Q naught. Fine. This question usually comes in exam. What does it imply? It means that test charge is very, very small. Test charge also creates its own field around it, but the intensity of the field which is created by the test charge is almost negligible comparatively to the source charge. All right. So it is defined as, and if we can write in this way also, F over Q naught. This is the magnitude. Is it okay? Hiram, tell here, is it okay?
Yes.
Now, electric field, it is a vector quantity. It is a vector quantity having same direction as that of force exerted on positive charge. Fine. Fine. So the direction of test charge means, for example, in this the source charge is positive. This is source charge. This is source charge and this is test charge. So the direction of the electric field. Now just let me know one more thing. Just let me know, Kiram, what is the direction of the force? This is positively test charge and this is source charge. What is the direction? Means the force exerted on test charge by this source charge will be towards right.
Yes.
So electric field will have the same direction. All right.
Okay. Yeah.
So it is a vector quantity having same direction as that of force exerted on positive test charge. Next, it is a SI unit. SI unit is Newton per Coulomb or volt per meter. Fine. Now direction. Just remember, due to positive charge, it is always away from it. Away from it. And due to negative charge, towards it. Moreover, let it be, this is uniform electric field. Fine. Electric field. And if I put negative charge in electric field, so it experiences force in the opposite direction of electric field. All right, Iram. And if I place positive charge in electric field, then it experiences force in the same direction of electric field. Is it okay till here, Iram?
Yeah.
Fine. You should be clear with the directions, because most of the students usually get confused while dealing with the numericals when there is a case of direction. Okay, is it clear till here?
Yeah.
Okay, just let me know one more thing. Did I teach you the question based on principle of superposition?
Yes. You did.
Okay. Now, question is, how's your mechanics, Hiram? How's your mechanics?
Not good.
Not good. What about FBD, free body diagram? Will you be means will you be able to draw them? FBD, free body diagram.
Yeah,
Okay.
maybe.
Now the question is given. Calculate electric field. We have to calculate electric field. Just a minute. There is a water drop having mass. Mass is given 10 is to the minus 3 kg, and calculate the electric field required to support a water drop of mass this, and having charge. Charge is given 1.6 into 10 to the minus 19 coulomb. So this is a water drop, and it is suspended in air. So now we have to calculate the value of electric field. Now it is given we have to calculate the value of electric field in such a way the water drop is suspended in air. The water drop is suspended in air. Mg. Now this is a water drop. It is suspended in air. So there must be two forces that are applied on this water drop. So mg will act in the downward direction. So there must be a force in the upward direction to balance mg. That is QE, the force exerted due to electric field. All right. Because since I told you E equals to F over Q, and if I have to calculate F, then it would be Q times E. Okay, Iram. Now there must
Yeah.
be an electric force which will be applied in the upward direction, that is QE. So mg must be equals to QE. And if you equate them, you'll get the answer. Now let me know the answer. Value of E. Calculate fast. 1 minute. And I'll give you one more question.
— 6.125 into 10 to the power 16.
What is M? 10 to the minus 3. What is G? 9.8 over 10.6 into 10 to the minus 19. Fine. So 6.125 10 to the minus 16.
16.
Okay. Newton per coulomb. Fine. I'm writing the next question. How many electrons should be removed from a coin of mass 1.6 gram so that it may just float in air in an electric field 10 raised to power 9 Newton per Coulomb. Fine. Directed upward. Fast. 3 minutes to do this question. Did you understand the question? Kiram, did you understand the question?
Yeah.
Okay, fine. Just do it. 3 minutes. Look here. How to do? The question is saying how many electrons should be removed from a coin of a mass this so that it may just float in air in an electric field directed upward. So electric field acting in the upward direction. So this is coin having some mass. So mg will act in the downward direction and QE will act in the upward direction. So again, QE must be equals to mg. All right, Iram. And we now, but what we have to calculate? We have to calculate number of electrons. So we can substitute Q equals to Ne. E is the charge on electron. So from here, N will be equals to mg over E capital E. Okay. Now let me know the answer. What is M? 1.6 into 10 to the minus 3 kg. J is 9.8. E is 1.6 10 to the minus 19 electron. 19 Coulomb. And 10 to the 9. What is N? Done, Iram?
Yeah.
How many electrons?
9.8
Hmm.
into 10 power 7.
Okay, good. Correct. How is your mechanics?
Not good, sir.
Kinematics.
Kinematics. Yeah, it's okay.
3 equations of motion. First is V equals to U plus AT. second is s ut plus half at square. Now v square u square equals to 2as. Fine, there are three equations of motion. Now the question, this question is from NCERT. There are two plates. One is negatively charged, second is positively charged. So just remember one thing, electric field, the direction of electric field is from positive to negative, all right? The direction of electric field is from negative to positive. And if you,
Positive to negative, right?
yeah, the direction of electric field is from positive to negative, means away from positive towards the negative. This is an electron. It is falling down. Fine. So let it be two plates. One of them is negatively charged and another is positively charged. So there is an electric field between the plates. Fine. The distance between the plate is stem is 1.5 centimeters, and the magnitude of electric field is given 2 into 10 raised to power 4 Newton per coulomb. Now we have to calculate the time taken by the electron to reach the lowest plate, means positive plate. Now we have to calculate the time. I repeat, there are two plates. One is negatively charged, second is positively charged. There is an electric field between the plates from positive to negative. This is an electron. It falls from it falls down. The distance between the plate is 1.5 centimeter. The magnitude of the electric field is given 2 into 10 to the power 4 Newton per coulomb. Now we have to calculate the time taken by the electron to reach the lowest plate. Take your time, 3 minutes. You have to use one of the equation from these three equations. Fine, use and let me know the answer fast. Three minutes, take your time. Do, then we will discuss electric field due to a point charge. Then I'll tell you how's your tension position. Look, we will do question on it also. But try this question. Question is very simple. You have to use second law of motion to calculate the acceleration. The distance between the two plates is given. Acceleration, we have to calculate it. U is 0. As I told you, the electron falls. Means in case of falling down, the initial velocity you have to assume equals to 0. Now the solution is U equals to 0. Fine. S is given, that is the distance. We have to change in meters. So 1.5 into 10 to the minus 2 meter. Now, what we want, we can use a second equation of motion, that is S ut plus half at square to calculate the time. Since initial velocity is given as 0. So this is s equals to half at square. So t equals to 2s over a. So t will come out 2s over a. Now the challenge is how to calculate a. So by second law, F equals to ma, and if a charge is placed in electric field, then the force experienced by the charge is equals to QE ma. So QE over m. Now substitute 2s QE m. Now substitute the value and let me know the answer. What is S? S is 1.5. This is 2, 10 to the power minus 2. What is mass of electron is, just remember, 10 is to 9.1, 10 to the power 31 kg. And charge on electron is 1.6 into 10 to the power minus 19. Into what is electric field? What is the magnitude of electric field? 2. 2 into 10 to the power 8. Now solve and let me know the answer fast. What is the answer, Iram? And this question has already asked in board examination. Iram, what is the answer? Iram, am I audible to you?
So I'm doing.
Okay, fine. Okay, fast do.
So I got under root 8.53 into 10 to the power 22. So you mute. So you mute. So you unmute.
What's the final answer?
So I got under
Two.
root
And if you take
8.5.
the square root of it, then 2.9 10 to the 9 seconds.
Okay.
Okay, Iram. One more question. Last question. The question based on tension. Okay. Now, this is a pendulum. Okay, this is a pendulum having mass 80 milligram. Okay, 80 milligram. The charge on pendulum is 2 into 10 to the power minus 8 coulomb. And the electric field is 2 into 10 to the power 4 volt per meter. Now, find the tension in the thread of the pendulum and the angle it makes with the vertical. Now, just we have to calculate angle, theta. Theta we have to calculate. The pendulum of 80 milligram carrying a charge this much is at rest in a horizontal uniform electric field. This is that it is at rest. Fine. So just remember one thing. tension will act in this direction, mg will act in this direction. Fine. The question is saying the pendulum is at rest. It means it is in equilibrium. So definitely the forces on it will be equal. Now we have to resolve it. If it is theta, it would be theta because both lines are parallel. So it would be alternate angle. It would be t of sine theta. It would be t of cos theta. And QE will act in this direction because this is electric field. Fine. Electric field. So we can use T of cos theta if the pendulum is in equilibrium or at equilibrium. So T of cos theta must be equals to mg and T of sine theta equals to QE. This is first equation. This is second equation. Now second divided by first, it will come out tan theta equals to QE. All right, Iram, till here.
Yeah.
So theta will come out tan inverse QE over mg. Now substitute the value, you will get the answer. Now what values are, what is Q? What is Q? Q is 2 into 10 raised to power minus 8. What is, this is charge. What is electric field? 2 into 10 raised to power 4. 80 milligram. 80 milligram. 80 into 10 raised to power minus 6 kg. And what is G? J is 9.8. Tan inverse. Now solve it. 4 into 10 raised to power minus 4 over 80 into 9.8. For simplicity, in this question, we can assume 10. If it is 10, then 8 into 10 raised to power minus 4. These two will cancel out. So tan inverse 1 over 2. Okay, this is the final answer. Okay, Iram. Is it clear to you?
Okay. Yeah.
Okay, fine. Let's move further. No, no.
So,
Yes.
so can you just wait for 5 minutes?
Sorry.
I'll be
Okay.
back.
Okay.
Can you just wait for 5 minutes?
Okay.
Actually, a
Okay.
phone call is coming. Thank you.
Okay.
Yes, sir. Thank you.
This question is clear to you?
Yeah.
Okay, fine. The next topic is, Iram, electric field due to a point charge. But before that, just a minute. Have you completed the homework?
Yeah.
Okay. Just a minute here. Electric field due to a point charge. electric field due to a point charge. So let it be a charge, capital Q, and we have to calculate the electric field at a point P at a distance R from the capital Q. So at point P, we have to calculate. Just remember one thing, most of the time what I noticed, most of the students get confused while calculating the electric field. Just remember, whenever we have to calculate the electric field, we always calculate at a point. Okay, and if we calculate the force, then we calculate the force between two charges, an electric field at a point, not a charge. We always calculate electric field at a point, not on a charge. So let it be a capital Q is a charge. If this is a source charge located at origin. Now, due to this charge, we have to calculate the electric field at point P at a distance R. So assume a small positive test charge is located at point P. Now, Iram, just let me know, what is the direction of the force exerted on capital Q, exerted on a small q naught? Towards right or left? What is the direction?
Towards right.
Towards right. Okay. Now this is the force exerted on it. Fine. And the electric field will also have the same direction because away from the positive. So by Coulomb's law, force equals to q naught over r square towards right. So by definition, electric field equals to F over q naught q naught will cancel out. Is equals to 1 over 4 epsilon q over r square. Now this is the required result. Okay, Iram? Did you get it? The derivation is very so simple. It's very simple, sorry. The derivation is very simple. This,
Yeah.
this relation you have to remember. An electric field is inversely proportional to the r square. And if I plot a graph between E and R, so it would be like this. Okay. Now, principle of superposition. Fine. Or we can say now electric field due to system of charges. So let it be a point P will be Q1, Q3, so Q2, Q3, and Qn. R1, R2, R3, and Rn. Fine. Now, if we have to calculate the net electric field at point P due to the n number of charges, so what we do, we calculate, first we calculate the electric field due to Q1, then due to Q2, and due to Q3 and due to Qn, and just sum up and the sum of them according to the vector law of addition. So E equals to E1 plus E2 dot 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 up to En. This is principle of superposition. Fine. Okay, Iram. Is it okay till here?
Yeah.
Now question. Now there are two charges, Q1 and Q2. Point charges. Q1 is 5 into 10 to the power minus 19 coulomb, and Q2 is 20 into 10 to the power minus 19 coulomb, separated by 2 meter. The distance is 2 meter. Fine. Now we have to calculate the point. Now we have to calculate the point where the electric field is 0. Now find the point where electric field equals to 0. Look, just go through the question, then I'll let you know how to do. Then shall I teach, Iram? Shall I tell you how to do? Look,
Yeah.
what we do, let it be X from either of the charts. If I assume X, let it be point P at a distance X from Q1, where the electric field is 0. So remaining distance will be 2 minus X. Now, if the net electric field at point P is 0, then electric field due to Q1 must be equals to electric field due to Q2. It means E1 equals to E2. So what is E1? 1 by 4 epsilon Q1 over X square equals to 1 over 4 epsilon Q2 over 2 minus X square. This will cancel out. Now what is Q1? Q1 is 5 over X, 5 into 10 to the power minus 19. And Q2 is 20 into 10 to the power minus 19 over 2 minus X square. These will cancel out. 5, 4. Now 1 over X square equals to 4 over 2 minus X whole square. So 2 minus X whole square equals to 4X square. 2 minus X square equals to, sorry, now we can take a square root both sides. So 2 minus X plus minus 2X. So there are two possibilities. First, 2 plus X or 2 minus X equals to minus 2X. So 2 equals to 3X. So X equals to 2 over 3. And second possibility is 2 equals to minus X, not possible. So at X equals to 2 over 3 meters from Q1, electric field is 0. So the final answer is, X equals to 2 over 3 from Q1. This is the answer. This kind of question is very important. Okay. Is it okay, Iram?
Yeah, sir.
Okay. Next question. Again, Similar type of question. This is plus 16 microcoulomb. The second charge is minus 9 microcoulomb. Find place 8 centimeter apart. Determine the position. Again, determine the position. Determine the position where E equals to 0. Fast theorem. 2 to 3 minutes to do this question. Fast. Hiram, am I audible to you, Hiram?
Yes, sir.
Okay, stay after the class for the assignment.
Sir, 4 centimeter.
Sorry, Hiram. What's the answer? Hiram, am I audible? Hiram, what is the answer?
So 1 minute. I think I've done some mistake. So,
Answer
24.
24. Just a minute. Let me do. This is 16. This is minus 9. So let it be x from this. The remaining will be 8 minus x. Okay, just Hiram, just let me know one thing. Where we have to assume the charge, where we have to assume the point. If we assume between, means in some midway between these two charges, let it be here. Okay.
Okay.
Now, what is the direction of the electric field due to positive charge at point P?
Away from the
Charge means
charge.
towards
Yeah.
towards right. Okay.
Towards right. Yeah.
And due to negative charge towards it.
Yes.
So do you really think, is it possible the charge will be in somewhere between the two charges? It's impossible because the direction of both the electric fields are same. So there is no possibility that electric field will come out to be zero.
No.
So we have to assume, okay, for now, just assume in means somewhere between the two charges. So k into 16 into 10 to the power minus 6 over x square, and k, negative sign you are not supposed to include because negative sign just for the direction. K will cancel out. 16 over x square equals to 9 over 8 minus x square. Now equate them. Now if we have to take square roots. It would be 4, 8 minus x plus minus 3x. 32 minus 4x equals to 3x. So 32, 7x. X equals to 32 over 7. Fine. Or we can write 4, 8 minus x equals to minus 3x. So 32 minus 4x equals to 3x minus 3x equals to 32 x. So x equals to 32 or x equals to 32 over 7. There are two answers. Okay. You made a mistake somewhere. Okay. Just check your calculation. 20 feet. How it is possible? You did the same way. Did you do the same way?
Yeah, maybe some calculation mistake.
Yeah, definitely. You made mistake somewhere in calculations. Let's go through it. Sh- sh- shall I shall I
No,
move?
just show me the calculations, please, sir.
Okay. 16, 8 minus x whole square
Just
equals.
scroll up, sir. No. Scroll down at me. Yeah, a little more. Yeah, stop.
Check.
Okay, sir.
Done.
Yeah.
Okay. Now, which answer we have to take it? Now, there are two possibilities, either x equals to 32 over 7 or 32. Now, if we take 32 over 7 centimeters, so 32 over 7 centimeters, is it less than 8 centimeter or more than 8 centimeter? Less than.
Yeah.
Okay, fine. So the point lies somewhere between these two charges. Is it okay?
Yeah.
But as I told you, if the point lies somewhere between these two charges, so it's impossible that the net electric field at that point equals to zero, because let it be P is the point between these two charges. So if I calculate the direction due to positive charge, then it is towards right, and due to negative charge, all again right. So the direction of both the electric fields are same. Hence, no, the electric field at point P will not be equals to zero. All right. The point must be beyond 8 centimeter. So x equals to 32 centimeter is the correct answer. Okay. From 16 microcoulomb. Okay. Is it okay?
Yeah, sir. It's okay.
Okay. Now what do you mean by electric field theorem?
It is the imaginary space around a charge.
What is the formula?
Uh, E vector is equals to F vector upon Q naught.
What is electric field due to a point charge? What is the formula due to a point charge?
E vector is equals to 1 by 4 pi epsilon naught Q by R.
Okay. If I increase the distance, the electric field will increase or decrease?
It will increase.
Okay. Okay. Electric field is a vector quantity.
Yeah,
Okay. What is the direction? If it is a positive charge, now, what is the direction of electric field at point P? Towards it or away from it?
away from it.
Away from point or away from charge?
Away from point.
Away from point means like this.
No, no, no. Yeah,
No, towards the point. Okay. Towards the point. If it is positive charge, then towards the charge. Towards the point. If it is negative, then away from it, towards it.
yeah, yeah. Okay,
Towards the charge. Okay.
okay.
Okay. Iram, stay for the assignment. Okay.
Hello, Iram.
Hello.
Yeah, Iram, please stay for the class assignment test, and I'm sharing it, okay?
Okay.
Iram, is it visible to you properly?
Yeah.
Okay, when you have done, and please let me know, I will scroll down.
Ma'am, can you please go scroll? Can you scroll, ma'am? Scroll.
Okay, Iram, if you have done, please submit it on the WhatsApp. Okay, Iram, I have received your answer sheets. You may leave now. Thank